Hi everyone. As mentioned, my name is Arkadiy Tetelman. I'm going to talk to you today about data-driven bug bounty. A little bit about myself. I work as an application security engineer. I used to work on the security programs at Twitter and Airbnb, which are the two programs I'm going to talk to you about today. All right, we're going to use the laptop. So the agenda for the talk, I'm just going to talk briefly about the logistics of the programs at Twitter and Airbnb, how we actually ran them, what that meant for us. We're going to jump into running a data-driven program, really the bulk of the talk. And I'm going to jump the gun a little bit, but it's the most important point is you're going to have limited resources and availability to actually get all the projects done that you want. So using this data-driven approach is going to let you prioritize your issues and measure ROI. We're going to talk about methodology and how you actually implement some of these things. And hopefully at the end there's time for some questions, but if not, I'll also be answering questions on PureList. So program logistics at Twitter. We launched with a single public program. Sorry, we have a single public program. This is opposed to using a dual, one public, one private program that you see some companies do. I'll explain that in a second. The soft launch was in May of 2014. It was initially unpaid, and then it moved to paid. The reasoning for that was to help handle the report volume a little bit better. A lot of times when you launch, you're going to see an influx of reports. You might want to work out the kinks in your process, make sure you have your workflow down pat. So for that reason, we launched with an unpaid program. It helped us keep the report volume down. Once we were ready, we moved to paid. We had frontline triage by NCC group. If you've ever worked in bug bounties, you know that there's a lot of noise. You get a lot of erroneous reports. So they would do the first line of validation. Any issues that they feel are valid, they're going to escalate to us, and we will look at them. We had anywhere between 4 to 6 AppSec engineers on the program, and we used 1-week rotations. So what that means is whichever engineer was on call that week, they would look at all of the issues that were escalated by NCC group as valid. We would validate them again, find the appropriate owner, really own that ticket for the lifetime and make sure that the team implements an appropriate fix, validate their fix, let the researcher know. Also, the on-call engineer would be the one that proposes bug bounty payouts, and we would review those once a week on Fridays. We paid out close to $1 million over 4 years, had 850 resolved reports, so it's a pretty healthy program, I think. If you want more stats, there's a blog post here. This is from 2016, but still pretty relevant. I think you can just Google bug bounty Twitter, or I will post these slides after the talk for the link. At Airbnb, like I mentioned, some companies use a public and private program just to help handle report volume better. That's exactly what Airbnb did until just recently. So for the majority of the program's lifetime, there was a public unpaid program, a private paid program. As of 1 month ago, in March of 2018, those were merged together into one single public paid program. I think this is always better to do. If a researcher submits you a report into the public program, they deserve to be paid if they found a valid issue, but you will get some more noise this way, so just something to be aware of. For triage, we have HackerOne this time. They provide a managed triage service. 4 AppSec engineers, 2-week rotation, but aside from that, pretty much the same as Twitter. And we've paid out $430,000 over 3 years with 430 resolved reports. Okay, so running a data-driven program, what does that even mean? Why would you want to do it? What are the benefits? And if you've decided to do it, how do you do it? My thesis is that data presents half of the value of a bug bounty program. Half of the value is going to be resolving issues. Obviously, you need to resolve the issues that you receive, but collecting these metrics around what are the vulnerability classes that you're seeing? What are your resolution times? When are bugs going past SLA? How often are they going past SLA? Which teams go past SLA? Which teams introduce bugs? How responsive are you on the bug bounty program? Are you fast to triage? Are you fast to pay out? All of these metrics, they're really important to collect, and I think they present as much value as actually resolving the issues themselves. So let's see some examples. What you're looking at here is a graph of vulnerability classes that we've seen. So the x-axis labels individual vulnerability classes, things like cross-site request forgery, server-side request forgery, cross-site scripting, open redirects, whatever. The y-axis is a count, so just simply count of bugs that we've seen over time. This graph is over all time data, but if we wanted to, we could also slice it by quarter or by week. We could look at week over week data, all sorts of slicing. So it's one of my favorite graphs. I think you immediately know your risk breakdown. You immediately know where you need to focus your energy. If you see a spike in XSS or more XSS in a quarter maybe, then you can invest in static analysis to make sure you've got output encoding or handling it at the templating layer or adding CSP, as we saw in an earlier talk. If you're seeing a spike in subdomain takeovers, you can add automated scanning for that. It really informs where you need to be spending your energy. So we take this graph and we feed it into quarter planning. We look at, you're going to have an entire backlog of projects that you could possibly work on. They're going to be informed by the impact that you think the project is going to have and the effort that you think it will take to implement the project. So having data like this available really informs the impact. We know immediately, the two highest categories here after security misconfiguration are sensitive data exposure and cross-site scripting, so we know that that's where we're going to get the most bang for our buck. Some of the other lower volume things, they might be interesting to look at or interesting to work on, but they're not that relevant for us, so let's not waste energy on them. You can also use this to measure ROI. So in addition to planning out ahead of your quarter what you're going to work on, at the end of the quarter you can come back or maybe wait a few weeks or another quarter after that and measure, did the numbers go down? Did this have the effect that I wanted it to have on my program and on these vulnerabilities? So that can be really valuable. You can look at, did it not have the intended effect, and maybe do a little postmortem about what happened. Maybe it did have the intended effect, but it wasn't as pronounced as you hoped it would be. Maybe you need to spend more effort on it. Being able to do that kind of analysis, I find to be really helpful. So the quarter that I took this screenshot, we did focus in on those second and third categories, the sensitive data exposure and cross-site scripting, and using this methodology of being able to measure after the fact, after we waited a quarter, we did see the downtick in the numbers that we wanted to see. One thing that I'll note about this is that you have to build out an internal taxonomy. You have to know what are your different vulnerability classes that you're going to tag issues as, what are the different components of the product that vulnerabilities fall into, who are the teams that are going to take ownership over that. You have to have this extensive tagging system and be really meticulous about tagging all your tickets. The way that we did this is we used Jira, and you can just create custom fields, but it took a lot of work to figure out the taxonomy that we wanted and also to actually label everything. Some things you can automate, but a lot of it is just manual labeling, and especially if you're doing this after the fact, if you've already launched a bug bounty program, it can be quite tedious to go back and tag the historical data, but I think it's worth it because in the end you get graphs like this. And also the taxonomy is flexible, it'll change over time. So if you'll notice the number one column here is security misconfiguration. That's kind of broad. It's really just a catch-all for us. That's why it's so much higher than all the other categories. As we see repeat vulnerabilities fall into there, we'll sometimes take those out and break them into their own category. Like one example I brought up earlier was subdomain takeovers. Those might be worth splitting out into their own category by now. Here's another fun graph. What you're seeing here is average vulnerability time to fix by team for the last 90 days. So the x-axis is individual teams. Every bar represents a team. And the y-axis represents the average time to fix in days for these vulnerabilities. So if you've ever done offensive security research or participated in bug bounty programs, then you've probably been on the other side of this graph, which is there's a 10x difference between the fastest and slowest teams in terms of resolving vulnerabilities. You've probably waited many months, sometimes more than a year, to see your vulnerabilities resolved. This is why. We try to work very hard to make sure that teams do resolve issues on time, but there's a natural distribution there that can be hard to control. In addition to time to fix by team, we also track things like SLA. So open tickets past SLA by team, which teams are consistently missing SLA. We look at trend lines and changes over time, all this sort of peripheral data. The reason this is super valuable for us is that you can hold teams accountable. When you see that a particular team is working 10 times as slow as your top team, that might be cause for investigation, and you can sort of drill down into that. I think even if you're the most empathetic security team in the world, which we should all strive to be, you're still going to have difficulties getting some of these teams to work with you. They have their own priorities, they have their own roadmap. They might just not even care. So when you bring data like this to the table, it can really help you. And on the flip side of that, when a team is doing well, you want to give them positive reinforcement. That's really important. Don't always be the bearer of bad news. Don't always come to the table and start talking about garbage fires or whatever. That's not going to really help the conversation at all. Celebrate good behavior, and that way teams will want to work with you. And as a concrete example of this, we had a specific team that hit a sustained 0 vulnerabilities past SLA, which we were very happy with. We were working with them for a while to get that accomplished. So once they hit that 0 vulnerabilities past SLA, we threw them a cupcake party. So that was pretty fun. This is another great graph. The x-axis here represents individual subteams this time. So every bar is a subteam. It's a stacked bar chart, which means that within the bars, the different colors represent volume of vulnerabilities by priority, so critical, high, medium, low. And the y-axis is count, so it's the number of vulnerabilities, open vulnerabilities by subteam and priority. Okay, does anyone notice a pattern in this graph? Does anyone immediately see something that strikes them as odd? Team 1 has an excessive amount of vulnerabilities. That's exactly correct. So what's going on with that team? I think that having a graph like this is really important for 2 reasons. The first reason, which is less important, I would say, is that it lets your security engineers know who the good and bad teams are. It's less important because they anecdotally will already know, but this way you can quantify it and put it on a graph. I think that's valuable. The second reason, the more important reason, is that you can use a graph like this to drive a conversation forward with that team. You can reach out to that team's manager or whoever the relevant stakeholders are for that team and start to figure out what's going on, how can we resolve this issue. And you'll notice I put in, but be careful. If you approach the manager of this team and you say, what's going on here? Why is your team not fixing vulnerabilities? What do you like? Why is your team so stupid? I don't know. Obviously, you wouldn't say that in a work environment, but people can be really passive aggressive, or they might have an attitude. Even if you have the best intentions, I think it's very easy for the recipient of this graph to get defensive and to not want to work with you because you're pointing out this problem in their team. So, but if you instead approach them and say, what's the root cause here? Is it a prioritization issue? Is it a resourcing issue? Can we provide you with more support? Are there misaligned incentives maybe? How can we work together to bring these vulnerabilities down or bring these numbers down? Then that can be really effective. And that's exactly what we did with this team. We reached out to them. We worked pretty closely with them for a quarter and established more open communication channels with some of the leadership on that team. And after a quarter, we were able to bring those numbers down significantly. Here's another graph for you. The x-axis here is simply the date. The y-axis is count of open vulnerabilities, and there's an individual line for every priority of vulnerability. So critical, blocker, major, what have you. This one's pretty standard. If you don't yet have the resources to invest in building your own custom dashboards and all the tooling around this, you can use some of the existing bug bounty dashboards. In HackerOne, you have a dashboard similar to this. There might be one in BugCrowd as well. So if you can't invest in that, you can use the dashboards, but I would say it is worth the investment. Once you can merge in your team data, your product component data, things like that, then you can really start getting the most value out of it. The other thing that I like about this graph is that it can be shared really widely and you can be visible with it. If you compare to the very first graph that we saw, if you remember, that was the one with the vulnerability classes, server-side request forgery, cross-site scripting, et cetera. That graph requires some domain knowledge to interpret, so it's really intended for the security engineers to see that graph and to be able to glean information from it. But a graph like this, everyone knows what an open vulnerability is. Anyone understands this graph. So you can put this into presentations. You can put it into a security newsletter, put it on your wiki, put it on a dashboard. I think one problem with security teams is many of them are invisible by default, and nobody thinks about them until there's a breach, and we all know how that goes. It's never a good feeling. So by sending out some of this data that you're collecting and being very broad and visible with it, by showing people the work that you're doing, the value that you're adding, the issues that are being resolved as a result of your work, that's going to benefit you a lot in the long term. You'll get more executive and leadership support, and you're also going to build more social capital. So if you, in the future, you do want to make a change that's a non-transparent change that does introduce some sort of friction, you're going to get less pushback from people because you're very broad and visible with your work. It's really important to measure improvement over time or lack of improvement. Again, that'll inform the business decisions that you're making. If you're seeing a lack of improvement despite efforts, why are those efforts not working? Or maybe you need to invest more, or you can dig in deeper into the data. If you are improving, then share those wins. It's really important. So use the data to drive business goals. If anyone was here for the first talk this morning about the starting a security program, I think it was a similar sentiment there. It's very important to be able to use data like this to drive what you want in the business. Okay, this one, the left-hand side is vulnerability sources. So you're looking at things like HackerOne or pen tests or wherever the report came from. The right-hand side are resolution states, whether the vulnerability is fixed or not fixed, if it's a duplicate, if it's a won't fix, invalid, whatever. And this is data over the last 90 days. I just thought it was a really interesting graph. You'll see that for this particular data set, we had something like 50% of our incoming vulnerabilities came in through HackerOne, and then maybe 35% came in from automated scanners. After that were third and first party penetration tests, then employee reports usually come in last, although sometimes they can be the most valuable. And again, you can watch for trends over time. So for example, if you see an increase from incoming scanner to closed as invalid, you're getting an increase in false positives, which you might anecdotally notice anyway, but now you can measure that impact. You can say, we need to tune the scanner. It's causing this much extra work for the operations team, or maybe we need to replace the scanner entirely or just get rid of it. Maybe it's not providing the value that we thought it was, given the increased workload. Or as another example, maybe you're seeing a decrease in the number of bug bounty reports. So that might indicate that you have an unhealthy bug bounty program and you should be investing more time and energy into that. Maybe the rewards aren't appropriate, maybe you're not responding quickly enough to people, so that should be investigated. And by the way, for building all of these graphs, you can use any tool that's appropriate for you, but these particular dashboards were built with a tool called Superset. It's like open source Tableau. We just connected it to Jira and made these graphs. So speaking of program health, you also will have measurements like what is your time to response? What is your time to bounty? How much bounty are you actually paying out? Are you on par with what your peers are providing? In the HackerOne directory, this is for Shopify, you'll actually get badges for if you respond quickly or if you bounty quickly, because that's super important to researchers. And BugCrowd does the same thing. You can see it says 75% of submissions were responded to within 1 day, which is really fast. That's a screenshot of Netflix's program. So probably the two most important metrics that you should be looking at here are response time and time to bounty. That's really what researchers care the most about. If you talk to security researchers, they really don't like being ignored. They don't like waiting. It even comes first above bounty amount. So sometimes they don't want or need the money, or sometimes they're just after the fame of it. But having a fast response time, probably the #1 most important thing. It's the least important data for you to actually collect. You'll notice that none of these figures or graphs were actually from our internal dashboard. These are public from HackerOne and BugCrowd, so you get it for free. You don't have to worry about collecting it. If you want to, you can import it into your own systems just so you don't have to look in 2 different places. That's fine, but it's also just there available to you. And it's also available to the researchers. They'll see all the same public data that you do. Why is this important? Well, there's the obvious reason of you'll have more researchers looking at your program and you'll get better reports. As we saw, I think 50% of our reports came in through HackerOne, so we wouldn't want to jeopardize that by having an unhealthy bug bounty program. But there's also some less obvious reasons. Researchers talk to each other. They all are on Slack together. They'll share reports with each other. They communicate about bad program experiences that they've had. If they've had a bad experience on your program, then they'll share that with other researchers, and those other researchers will then be less likely to participate on your program as well. And same thing for bad response time or unfair bounties, things like that. So by staying on top of these metrics and making sure that they are all healthy, it doesn't just ensure that you have strong, healthy reports. It also prevents this bad ripple effect from happening that can happen when you have a slow response time, for example. And you also get early notifications and access. What I mean by that is we've had researchers reach out to us on Slack before they even submit the report. A researcher will come out and say, hey, I see something on this web property, or I see something on this endpoint. Is this expected? This looks a little bit weird. So we will receive early notification sometimes before the report is even submitted, and that's valuable to us. And we also even get early access to blog posts when we have very good relationships with those researchers. They'll say, here's a blog post I want to publish. Here's the date that I would like to publish it by, and we might be able to adjust the date a little bit, or even suggest modifications, usually around the timeline, because we have a better view of the internal timeline of when things were deployed and fixed. So we might say, can you adjust this date to be more accurate? And they'll actually take our feedback and do that. Really valuable to have a good relationship with your security researchers. I thought I would talk a little bit about the methodology also. That's all great. I hope you see the value of why you would want to run a data-driven program. How do you actually do it? If you're just launching a program, if you don't have a bug bounty program at all, start with a pen test and assess yourself. Don't just launch a bug bounty program. I think that will be very hard to get right. Most likely you will see a large influx of issues, and you might not be equipped to handle all of them, and it's going to lead to some sour experiences for the researchers. So assess yourself first. Figure out what your weak spots are, know them, and write them into the program scope. When you do launch your program, launch it as a private program first. Make it a limited scope and have just a small number of researchers. Make sure that you ramp up slowly so that, again, you can work out any kinks in the process. Everything is running smoothly. Tune your workflow. Make sure that you are able to triage tickets on time. Make sure that tickets are getting resolved on time. If there's any systematic issues that you're seeing, maybe it's time to resolve those before doing a full rollout. and only go public when you're ready. What does it mean to be ready? There's a lot of different ways to define this, but at a minimum, you should have your process down pat. Like I said, everything should run smoothly. You should be able to triage, validate, assign, remediate issues. I would suggest having a significant number of researchers in your private program at this point, maybe like a few hundred at least. You maybe are starting to see a downtick in the number of reported vulnerabilities to your private program. That's a good indication that you might be ready to launch, assuming that you don't have an unhealthy program. And you should also be ready to launch, ready to handle the influx of issues. Anytime you go public, and especially if you start paying out for vulnerabilities, you're going to see a large group of people immediately target your application, and they're going to find things just because not enough people have been looking before. So you need to be ready to handle that. And regardless of whether you're starting or have already started a program, as I mentioned before, you've got to define that taxonomy. You've got to, specifically, I think these are the most important things, tag the vulnerability class, tag the source of the vulnerability, tag the team that it belongs to, and keep track of SLA. I think just those 4 or 5 things will get you really, really far in terms of what value you get out of this data. So in conclusion, data-driven bug bounty, super valuable. It informs your security posture. It's input into your security roadmap. It helps you drive conversations forward with other teams. It lets you be visible in your organization, and it helps you have a healthier bug bounty program. And in terms of methodology, I would just say start small and scale out. It's better to go too slow than too fast. So with that, I think there's a few minutes for questions, and I will also be answering questions on PureList. Yes.
Hey, so everything you're talking about is great if you actually do that for the primary business. Do you see any value in having a bug bounty program if there's a corporate, the corporate function is the main function where it's not doing development like Netflix and
So the question was, is there value in doing this sort of data collection and bug bounty if the primary if it's a run-of-the-mill Walmarts of the world, more corporate-y. Walmart is getting pretty advanced. Walmart has some pretty large stuff. They're making a lot of acquisitions. I think in my ideal world, everyone would have a bug bounty program. I think it's very valuable, but it's mainly a resourcing issue, especially for a lot of SMBs. Like, they don't even know how to set up a router. There's no way they can do anything like this. So I think that managed services are probably the answer there. Some of these managed services should provide services to the smaller businesses, and those providers are the ones who need to run bug bounty programs, if that makes sense. Yeah? Can you speak up? The question is, have I thought about posting the taxonomy that I used? It's pretty much, so the vulnerability classes that you saw there, that was pretty much it. I don't know that there's much else. The teams are obviously going to be internal. Every company has a different team. The sources are probably going to be mostly identical for every company. Your bug bounty, you've got scanners, and you might break it out to be more granular than that. But I think the ones that you saw on the slide are pretty representative. With the one thing I would really like to fix is the security misconfiguration. Like I mentioned, it's quite broad right now. So.
The internal find seems really small. Could you elaborate on why you think that's the case?
My internal what?
You had a class that showed the category of who's finding the bugs and the internal, who's discovered internally.
Oh, I see. So the question was, on this one slide, employee reports comprises a very small portion of the overall number of reports. And can I speak to that? I think it would be great if more employees reported something, usually they're the ones with the most information. They're really the boots on the ground, and they can hear and see everything. It all comes down to largely security culture, I think, and sort of evangelizing that security culture and providing people more, again, visibility. I think if you just share, here's all the stuff we're working on, here's how security is important to the business, then sometimes people will start to volunteer, come out of the woods and say, hey, did you know about this issue? Or, hey, did you know that this service is accessible from the internet, or what have you? It would be great if we got more reports. I think in practice, it is probably relatively small for most companies. I think bug bounties and scanners are going to always comprise the majority.
Unfortunately, that's it for questions for now. Let's thank our speaker again.
Thank you.